In this video, we are going to discuss the principles and the basic concepts of sampling, what is meant by sampling, why we need sampling, and how we can assure that the sample be representative for the parent population so that we can generalize the results, etc. We're going to show such opinions. If we can look to this illustration, we can see that we have about 4 types, and we'll come to discuss this later on. But simply to start with, this illustration is very important so that we can pave the way for understanding what's meant by sampling. For example, simple random sampling, all elements are considered and each has equal chance of being selected, while in the stratified, the population is divided into subpopulation or stratum, subjects selected randomly so that the sample will be representative for the whole strata. And then we can talk about systematic, every nth element chosen started at random and picking every nth element in succession. And also we have the cluster sampling, where population is divided into clusters. Random samples of clusters selected from as simple random design. And this is available in Pinterest, this web address, so that you can access it to understand more. But this is to start with, to understand that what are these samples, or the type of samples that we use in health research and in medical research in general. Now we talk about the sample size. The estimation and sampling technique are important elements in research, and they are to be considered at an early stage of the proposal development. As you are writing the proposal, one of the most important elements in the methods is to write about how we are going to estimate the sample size and how you plan to draw a representative sample for the parent population. How the sample is selected from the parent population will govern if ever the accomplished result or the achieved results would be generalized to the parent population. In other words, that the sample should be representative for the parent population so that at the end, the achieved result or the accomplished result can be generalized to the parent population. It's necessary to understand and apply the principles of sampling technique and sample size estimation, because this is very important. Otherwise, if a researcher carries out the sampling technique or his estimation of the sample size in a poor manner, then the whole research project will be at risk of being of poor quality, and the results will be questionable. So it's very important to understand exactly how to estimate the sample size that will be representative, and how to select the sample elements so that the sample will be representative for the parent population. This is very important aspect that should be cared by any investigator who is interested to conduct a quality research project. If we are interested to draw a sample of school children, for example, to study the epidemiological pattern of schistosomiasis, then it is important to raise questions such as who are the school children, how many of them, how they are to be selected, the total number, and how they are distributed. If there are strata, for example, in primary school, we have first year, second year, up to 6 or 7 or 8 years, or whatever it is. So there are strata. So we have to care that the parent population, when is stratified, then the sample should be also stratified so that it can be representative for the parent population. The rationale for sampling is that the sampling is less expensive to conduct for a study, the representative sample of the parent population, rather than to study the whole population. For example, if you have population of thousands or millions, or so it's more less expensive, and it's more costly that you go for studying the whole population. So we resort to sampling because it is less costly, it's less expensive than to study the whole population. And as well, it is time saving. The time needed to conduct a study using a representative sample definitely is shorter than to study the whole population, which you need a hell of time so that you can finish the study. Thus, the results can be obtained within a reasonable time, and then amenability to errors. The estimates on a representative sample are less amenable to errors in comparison to study the whole population. If you study the whole population composed of 30,000, for example, then you are more amenable to have errors, to have mistakes in the estimation, in the calculation, in all these, in your results. So it's important that to understand why or it is justifiable to resort to sampling rather than study the whole population. The population or the universe, a population is any entire collection of people or collection of animals or plants or things from which we collect data. That is the parent population. But in medical and health research, we talk about, for example, the population as TB patients attending referred clinics. We talk about the medical doctors employed in a certain hospital or a nursing staff employed in a rural hospital or whatever it is like. This is a population. So we are in the entire, we have the entire group. We are interested, which we wish to describe and to draw conclusions, to conduct the research about example, about them. For example, if we have a population that is composed of medical doctors in Khartoum Teaching Hospital, I'm interested to study conduct a study about how they perceive and how they practice informed consent. Then our population is the medical doctors currently employed in Khartoum Teaching Hospital. So we are interested to conduct the study among them so that we can understand their knowledge, their practice, their attitude, and how they perceive about the informed consent and how they practice informed consent from patients or from co-patients and so on. For example, in order to make any generalization about the population, the sample that is meant to be representative of the current population, and this is very important. For each population, there are many possible samples. A sample statistic give information about corresponding population parameter. For example, if we talk about the sample mean for a set of data, would give information about the overall mean. Here also we have some other references that you can go to it. The sampling unit, a unit is a person or animal or plant or thing, which is actually studied by the researcher or by the investigators, the basic object upon which study or experiment is conducted. We talk about the sampling unit as a person, an individual. If you go to our example that we talk about knowledge, attitude, and practice of medical doctors about informed consent. So here the sampling unit is the medical doctor. For example, a person could be a monkey, could be a sample of soil, a pot of seedlings, postcode area, doctor's practice, whatever it is. When we talk about representative sample, a representative sample is a sample which for a specified set of variables resembles the population in certain specified and characteristics, thus yields results within acceptable limits set about the corresponding population values, for example. And the only statement that or claim that the sample is representative of the current population tells us nothing about if it is representative actually. That is, in the sense we have to ensure the representation through the process in which we draw the sample, rather than just to state that it is a representative sample. And otherwise, it will be something not acceptable to just to state that it's representative, and actually it is not representative in reality. A sampling frame, when we talk about a sample frame, is just a list of the people that are in the population. For example, we talk about a hospital admission list as a sample frame. We talk about hospital patient list. We talk the list of the workers in a factory, the list of families in a village with children under 5. We talk about the list of medical doctors employed in Khartoum Teaching Hospital, as we have just mentioned in that example, where we're interested to study about the attitude towards informed consent. The sample is a group of units selected from a larger group. resulted from the parent population. By studying the sampling, it is hope, or we are interested to draw a valid conclusion, to draw valid results that are representing for the parent population, as we have mentioned. A sample is generally selected for study because population is too large to study in its entirety, and the sample should be representative of the general population. Well, this is best achieved through random sampling technique, as we'll come to discuss in later videos about the sampling techniques. Also, before collecting the sample, it's important that the researcher carefully and completely define the population. It's very important to find the population so that you can draw the sample properly. You have to define exactly the population: school children, medical doctors, nursing staff employed in a certain hospital. You have to define them exactly, and to mention at least the inclusion and exclusion criteria about that population whom you are going to include and pass. The sampling error, we refer to the difference between the value of a sample statistics, such as sample mean or any other measurements, and the true value of the population parameters, such as the population mean. If you compare the sample mean, we call it sample statistics, like the arithmetic mean. We measure it in a sample, and then usually there is a difference. Talk about sampling error, there is a difference between the sample statistic and the population mean. And this is very important, that some error is always present in sampling with random sampling methods. The error is random rather than systematic. We talk about the response rate also, the presence, the percentage of people in the sample selected for the study who actually participate in the study. And those are the individual who participate. And because it's also important when we come to estimate the sample size to care for the non-response rate and how it is, so that it will be considered in the estimation of the sample size. This is a very important step. Because usually those who do not respond may have different characteristics from those who actually participate. So in estimation of the sample size, we have to consider about the non-respond or the participant who do not respond in the study. Thank you very much.